So good evening to everyone, beta. So you just started with your escape velocity in the last session of your class. Okay. Sure. Take next heading, beta. Motion of planets Hmm. Motion of planets and satellites. Okay. You know that planets move around the sun due to what, beta? Gravitational force of attraction. And the path of the planets are what? Generally elliptical with the sun at your focus. Okay. Planets move around sun due to gravitational force. Okay. What will be the path? The path of these planets are elliptical with sun at focus. Okay. So what is the path of this one? All of them are moving in elliptical, and what is the responsible force for that? Would the gravitational force of your attraction. Okay. Based on this one, we are having three laws which we are called as of your Kepler's laws of your planetary motion. If I'm talking about first law, Kepler's first law, are also known as anyone with law of orbits. Kepler's first law, or also known as of your law of your orbits. What is this says? All the planets revolve in the elliptical orbit with the sun at your focus, which is known as of your law of your orbits. Like say this is your elliptical path. This is your semi-major axis. This is your semi-minor axis. Okay. Now here there is somewhere here sun, and all the planets are revolving around this one. So this is your planet. This planet is been revolving in the elliptical orbit around this sun. If it is somewhere here, here it is having a velocity v1. If it is here, the velocity here is say for example v2. Okay, and sun is at your focus, and this is your planet. Am I clear? So all the planets move in the elliptical orbit with the sun at the focus, which is known as of your law of your orbit. All the planets move in elliptical orbit. Move in elliptical orbit with the sun at a focus. Done, beta? Now here what will be using? For all the planets which are moving in elliptical orbit, beta, we conserve the momentum and as well as of your energy. For motion in elliptical orbits, we use number one, angular momentum. We use your angular momentum conservation. Angular momentum conservation. That means initial angular momentum must be equal to final angular momentum. So mass of the planet m1 v1 into r1 must be equal to your m2 v2 into your r2. Mass of the planet will be the same, so I'm taking it one as of your m itself. Okay, from here to here this distance will be equal to, from here to here this distance will be equal to r1, and from here to here this distance will be equal to your r2. Mass of the planet will be equal to your m. Okay, and velocities are v1 and as well as of your v2. And also we use here right now energy conservation. By energy conservation, we can say that total initial energy must be equal to final energy during the rotation. Okay, that is half into m into v1 square. Potential energy is right now for me plus minus of capital G capital M small m divided by r1 must be equal to your half into m into your v2 square plus this will be equal to minus capital G capital M small m divided by your r2. Small m is the mass of the earth and capital M is the mass of the, capital M is equals to mass of sun, and small m will be equal to what beta? Mass of your planet. Here we are taking as of your earth. Yeah, sure. So what is the condition? We are applying the law of conservation of your mechanical energy, very important, right beta? And we are also applying the law of conservation of your angular momentum. So initial angular momentum must be equal to your final angular momentum. That is m1 v1 is equals to your m2 v2. So I can write from here v1 r1 is equals to your v2 into your r2. Isn't it? That means I can write here v1 divided by v2 is equals to your r2 divided by r1. Relation between velocity and the distance between them. R1 is known as semi-major axis and R2 is known as of your semi-major axis. Isn't it? If the planet is very far, the distance is known as of your aphelion. If it is very nearer, that will be called as what for me? Perihelion. Am I clear? The distance of the planet, if the sun and the planet is nearer, the distance R1 is known as what for me? Your perihelion. Is known as perihelion. If it is larger, this distance is known as of your aphelion. Then, and from here to here, right now, if I'm taking the A will be called as of your semi-major axis, and B will be called as of your semi-minor axis. So from here to here, if I'm taking this one as of your A, done, madam? Yeah. So nearer distance is known as of your aphelion, and farther distance is known as of your, right now for me, aphelion, and nearer distance is known as of your perihelion. We are applying the law of conservation of mechanical energy. Total initial energy must be equal to your total final energy. Okay, total initial energy must be equal to total final energy. Am I clear? Sure. Next one. Kepler's second law. Kepler's second law are also known as law of areas. Kepler's second law are also known as law of your areas. Very important. But this says that every planet sweeps equal areas in the equal intervals of your time. Okay, every planet whichever has been revolving around the sun, every planet revolves around the sun in the elliptical part, and it covers equal areas in the equal intervals of your time. So can I say the condition right now here? The radius vector from the sun, the radius vector from the sun to the planet sweeps sweeps equal areas in equal intervals of time, in equal intervals of your time. That is, aerial velocity of the planet will be equal to constant. That is, aerial velocity of the planet is constant. Okay, that means aerial velocity means what, beta? dA by your dt. dA divided by dt is equals to your constant. That means A1 divided by T1 will be equal to your A2 divided by T2. Aerial velocity dA divided by dt is equals to your constant. Okay, so we have a proof of this one also. So don't bother about that one. You just write dA by your dt is also equal to your L divided by 2 times of your M. L is your angular momentum, M is nothing but of your mass of your planet. Okay, so dA by dt is nothing but dA by dt is equals to L by 2m. L is your angular momentum. So constant aerial velocity is a consequence of what? Law of conservation of your angular momentum. So dA by dt is equals to L divided by 2m. dA by dt is equals to your constant. That means it covers equal areas in the equal intervals of your time. So A1 divided by T1 is equals to your A2 divided by T2. Clear? Sure. Third one. Kepler's third law. Kepler's third law. Kepler's third law, or also known as of your law of periods. Law of periods. Law of periods. किसकी डेफिनेशन याद है बेटा? वेरी फेमस. Okay. So what do you mean by the law of your periods? Kepler's third law. Square of the time period is directly proportional to your cube of the average distance between them. That is nothing but a cube. That is, t square is directly proportional to your r1 plus r2 divided by 2 whole cube. Actual formula. You know what is r1 and r2? R1 and R2 is nothing but of your distance of your planet from this sun. Okay, like say for example, if this is your elliptical path and this is your axis, and somewhere here is say for example your sun. Say suppose sun. So here the planet is moving with a certain velocity. And here is a planet. This planet is here moving with velocity v1. This planet here it is moving with velocity v2. From here to here this distance is r1. From here to here this distance is right now for me r1. Okay. So nearer distance r1 is known as of right now for me perihelion. This distance is known as what for me? Perihelion. And larger distance is known as what for me, beta? Aphelion. Okay. What is A here, beta? A is your semi-major axis. I'll write here. This is your semi-major axis. This one is your semi-major axis. This is A. A is known as for me your semi-major axis. Okay. And B will be your semi-minor axis. R1 is the shortest distance of planet from the sun, perihelion, and R2 is the largest distance from the sun, that is known as of your aphelion. Okay, and here very important formula beta. I'm not deriving that one, just you try to remember it. V1 and V2 can be calculated by the formula. V1 is equals to under root of your, this will be Gm divided by your A, that is nothing but of your semi-major axis, into 1 plus E divided by 1 minus E. E is known as eccentricity. E is known as what beta? Eccentricity. Eccentricity. That value will be given beta, but for MPC students, we know the proof of this one. So don't bother about that all proofs and the formulas of that one. That is of no use for the medical students. Same way, V2 can be calculated with the formula under root of your Gm divided by A into 1 minus E divided by 1 plus E. That's the only thing you need to remember. 1 is above plus, 1 is below minimum. So what is V1 and V2 here right now, beta? V1 is right now for me perihelion. V1 is nothing but for me perihelion. That is nothing but maximum velocity. So this is your V max. And this will be equal to V minimum. Minimum velocity and maximum velocity. Am I clear? A is semi-major axis, E is your eccentricity. Am I clear? Small m is the mass of the planet and capital M is your mass of your Earth. Clear? So square of the time period is directly proportional to your AQ. If it is asking in percentage beta, how do you write the value of your T square? So here from the errors concept, if I am writing, T square is directly proportional to your, it will be your K into your AQ. A is right now for me what? Semi-major axis. In terms of error, it is 2 into delta T divided by T is equals to K is constant. So it is 3 into delta A divided by A. Percentage if I am writing, delta T divided by T into your 100 is equals to 3 by 2 times. This is your delta A divided by A into your 100. Okay. Square of the time period is directly proportional to right now for me cube of your semi-major axis. Square of the time period is directly proportional to your cube of your semi-major axis. A is your semi-major axis. And A can be written in terms of mean radius of R1 and R2, that is R1 plus R2 divided by 2. A is also called as of your mean distance. Am I clear? Sure. The next one. Very important formula. Orbital velocity. I hope everyone remember the formula. What do you mean by orbital velocity? Orbital velocity. Orbital velocity represented by V naught. Okay. Orbital velocity is nothing but the velocity with which a planet is revolving around the Earth. That is known as of your orbital velocity. Like say for example, this is your Earth of radius capital R, mass of Earth is M. Okay. And here there is somewhere your planet. Okay. And it is revolving in the circular orbit with a certain velocity. This velocity will be equal to orbital velocity, and path followed by this one is right now for me what? Spherical. Okay. The distance of the planet from the center of the Earth is small r, and from here to here this distance is nothing but equal to your h. And what is the force responsible for a particle to move in the circular path? Centripetal force. So can I say that centripetal force must be equal to your gravitational force? Centripetal force m into your v naught square divided by r is equals to gravitational force capital G capital M small m divided by your r square. Done? No. Small m and small m will get cancelled here, and this r and 1 square will get cancelled. So v naught square is equals to G into m divided by r. So from here I can write orbital velocity v naught is equals to under root of your G into m divided by r. So this is your orbital velocity. V naught is equals to under root of your Gm divided by r. Okay. What is small r beta here? Small r is equals to capital R plus of your h. Clear? Chalo. If h is very small, if h is much lesser than the radius of the Earth, orbital velocity will be equal to under root of your G into m divided by, this will be equal to actually r plus h. So this will be written as of your under root of your G into m divided by your, if h is very small, we directly write in terms of your capital R. Okay. So orbital velocity is equals to under root of your G into m divided by r. In terms of small g, we know that small g is equals to capital G capital M divided by r square. So capital G capital M is G into your r square. If I substitute that value here, we'll get V naught is equals to under root of your G into your r. This will be the orbital velocity. Okay. So can I say that orbital velocity will be equal to how much for me? As escape velocity is equals to under root of your 2g into your r. So can I write that VE is equals to under root of 2 into your V naught, isn't it? So or else I can write orbital velocity is equals to escape velocity divided by root 2. Relation between the escape velocity and orbital velocity. VE is equals to root 2 times of your V naught. Okay. So this is your orbital velocity formula in terms of small g, and this is the orbital velocity in terms of capital M. If mass is not given and density is given, mass can be written as volume into density. Volume of the spherical body is 4 by 3 pi into r cube. And escape velocity is root 2 times of your orbital velocity, or orbital velocity is 1 by root 2 times of your root 2. Okay. Chalo. Next one. Time period. Time period of your satellite represented by capital T. What is time period formula beta? Whenever a particle is moving in a circular path, time period is equals to total distance divided by velocity. Total distance is circular, so it is 2 pi into your r divided by orbital velocity v naught. Clear? So this value will be equal to 2 pi into small r divided by orbital velocity is under root of g into m divided by small r. Isn't it? So that will be equal to 2 pi into, if r is going up, this will be r power of 3 by 2 divided by under root of your g into m. Okay, so that means I can write here right now, this is equals to 2 pi r power of your 3 by 2 divided by, this will be under root of your small g into your r square. I can even write like this, isn't it? So can I say that from here we are getting the Kepler's third law? T is directly proportional to r power 3 by 2. This is also your Kepler's third law. Clear? So can I say that time period is independent of the mass of the satellite? Capital T is very important point to remember. Capital T is independent of, it is independent of mass of your satellite. Mass of your satellite. Clear? Now one more. If h is very small or nearer to the radius of the earth, then time period will be given by the formula T is equals to 2 pi under root of your, this value will be equal to r divided by your g, because small r to the power of 3 by 2 is nothing but equal to how much? Capital R plus h to the power of 3 by 2. Isn't it? So if I substitute this value in this one, comparing these two equations, we are getting the time period T is equals to 2 pi under root of your r by g. And the value of this time period is equals to your 84.6 minutes. That is approximately equal to 1.4 hour for one complete rotation. So this is the time period of your satellite if it is very nearer to the surface of your earth. Am I clear? Next one. What is an angular momentum of the satellite? Anyone? Angular momentum of satellite. Angular momentum of satellite. Angular momentum is given by the formula L. L is equals to your m into v into r. L is equals to your mv into your r. So that is equals to your m into v. V value is equals to under root of your g into m divided by your r, orbital velocity, multiplied with your r. So if I take this r inside and m inside, this value will become for me under root of your, this value will be equal to m square. This will be g into m divided by r into, this is your r square. So r and this square will get cancelled. So that is equals to under root of your this G capital M into your small square, small m square into r. This will be the angular momentum. Very important formula. L is equals to root of your capital G capital M square into your r. That means in a satellite the force is central. So torque will be equal to how much for this one? 0. So torque acting on the planet which is revolving the circular path will be equal to 0. That is the reason the angular momentum of the satellite is said to be conserved. Am I clear? Sure. Next one. What is the energy of the satellite? Energy of satellite. Energy of satellite. We have kinetic energy, we have potential energy, and we have the total energy. If I'm talking about kinetic energy, kinetic energy of the satellite will be equal to half into m into your v naught square. So that value will be equal to your half into your m. V naught square is right now for me under root of your capital G capital M divided by small r whole square. So this value will come out for me half into your, this one is right now for me capital G capital M into mass of this one divided by your r. Yeah. What will be the potential energy, beta? Potential energy U will be equal to minus capital G capital M small m divided by r. This is the potential energy. And third one is the total energy. Total energy of the satellite, that is E, will be equal to sum of your kinetic energy plus of your potential energy. Okay. So if I add both of them, see what I'm getting. One is half, another is one minus one. So total energy will be equal to minus capital G capital M small m divided by r. So this will be the total energy. Am I clear? So can I say that kinetic energy is equals to minus of your total energy? And in the same way, potential energy is 2 times of the total energy. Am I clear? So this is your total energy, and relation between them is kinetic energy is minus E and potential energy is 2 times of your energy E. Am I clear? So this is your kinetic energy formula and this one is your potential energy formula. Sure. Next one is binding energy. Did anyone remember the binding energy? Very important. Binding energy is nothing but what? See, the total energy of the satellite in orbit is what? Negative. That means negative energy. So satellite is bound to the Earth. There is a central body. So the energy required to bring the body or to move the satellite from the orbit to the infinity is called as what? Binding energy. That means equal and opposite energy you should give it. Total energy is minus, so you give the positive energy for that one. So plus and minus will become how much for me? So net will become for me 0. So can I write here definition? The energy given, the energy required, the energy required to remove the satellite, to remove the satellite from its orbit, from its orbit to where? From its orbit to infinity, to infinity is called binding energy, is called binding energy. So binding energy will be equal to minus of your total energy. So what will be the formula for binding energy right now? So binding energy will be equal to minus of minus, it will become for me plus. So it is capital G capital M small m divided by r. So this is your binding energy formula. Clear? Next one, geostationary satellite. Geostationary satellite. Geo means what? Earth. Satellite which is moving with the same speed as that of your Earth is called as of your geostationary satellite. Okay. So the satellite which appears to be stationary relative to the Earth is called as geostationary satellite. And the satellite will always be overhead of a particular place at the equator. So the time period of the satellite will be equal to how much for me? 24 hours. So time period formula for this one is T is equals to 2 pi into your 3 by 2 divided by under root of your capital G into your capital A. That is equals to your 2 pi into your, this is capital R plus H to the power of 3 by 2 divided by under root of your capital G into your M. The time period of this one will be equal to how much for me? 24 hours. Okay. What is the orbital velocity speed beta with which, what is the speed with which the satellite will is revolving on the circular path? I forgot to write this one. So orbital velocity will be approximately equal to V naught is the almost all equal to your 8 kilometer per second. 7.9 लेते हैं, but for calculation you can take approximately 8 kilometer per second. So every satellite which is revolving around the surface of the earth will be moving with a speed of what? 8 kilometer per second. Am I clear? Sure. तो प्रॉब्लम्स प्रैक्टिस ज्यादा करना बेटा, फॉर्मुलेस बहुत है इसमें, भूलने के भी चांसेस बहुत ज्यादा रहते हैं. One more and very important, shape of the orbits. Shape of the orbit of a satellite. Shape of the orbit of a satellite. Okay. This is your Earth. If a planet is projected from here, this is the center, and this is the small r total. The particle is being projected with a certain velocity. You're right, v. This is the radius of the Earth. There is nothing but r, and this is the center O. Okay. So velocity with which the orbit is being projected. Okay. So what will be the path followed by that path? Okay. V is the velocity of the body. Sure. See here. If given velocity is, if I'm projecting a body with certain velocity v, if my given velocity is lesser than orbital velocity, then satellite does not remain in circular path. So it traces the spiral path and ultimately falls onto the Earth. So what is the path of this one? Spiral path. Okay, and falls on Earth finally. Okay, the same way. If the given velocity is exactly equal to orbital velocity, then the satellite will be revolving in the circular orbit. Try to remember this one. And if your velocity, if orbital velocity is lesser than of your v and v is lesser than of your escape velocity, then the path of this one will be equal to your elliptical path. Okay, it is in between the escape velocity and orbital velocity. And if the body's velocity is exactly equal to escape velocity, if given velocity is equal to escape velocity, then the planet will be moving in the hyperbolic path. It will be moving in the hyperbolic path and will escape out of the gravitational field and escape from gravitational field. Escape from your gravitational field. These are the basic things you need to remember. Okay. Binary sort system is also there, beta, but don't bother about that all relations. You just try to remember these basic things. That's more than enough for me. So what will be the shapes of this one? If v naught is lesser than v naught, if the given velocity is lesser than orbital velocity, then the body will never make a circular path. It will fall back to the surface of the Earth, and the path will be the spiral. If v is equals to v naught, then obviously the path will be circular. If it is in between orbital velocity and escape velocity, it will be your elliptical path. If v is equals to escape velocity, it will be your hyperbolical path and it will be escaping from your gravitational field particulation. Clear? Okay. So this was something related to your escape velocities and as well as of your orbital velocities and your binding energy. Total energy. Potential energy kare na apan? Have we done about your gravitational potential energy? Escape velocity we have done. Potential energy we have done it. Relation between capital G and capital T. Yeah, gravitational potential also we have done due to the shell and due to the solid sphere. These are very important beta. Okay, and we'll start doing the numerical. So relation between them is potential energy and gravitational field energy relation also we did, and graphs also we have done. Almost all the formulas. We are left out with one small topic beta, that is about your cutting. If one small part is removed from the heavier part, how do you calculate the gravitational field? For that one, we need to have the concept of your removal part. Okay, I'll just do that one once. और इस पे हम लोग एक 50 to 80 अच्छे प्रॉब्लम्स करेंगे, लिविंग योर पीवाईक्यू क्वेश्चंस. पीवाईक्यू के क्वेश्चंस आप लोग एक बार ट्राई कर लीजिए, एंड ऑल दी प्रॉब्लम्स आपको एक से दो बार करना पड़ेगा. देन ऑल दी फॉर्मूला शुड बी ऑन योर हैंड. देन यू कैन डू द रिलेटेड प्रॉब्लम्स रिलेटेड टू दिस वन. ठीक है, चलो. आपके पीवाईक्यूज खत्म करो बाय द ट्यूसडे. ट्यूसडे तक आप लोग प्लीज ट्राई टू कंप्लीट योर ऑल पीवाईक्यूज ऑफ योर ग्रेविटेशन. मैंने आप लोग एक असाइनमेंट भेजा, थोड़े अच्छे क्वेश्चन है बेटा. वो जब भी कर सकते हैं पूरे प्रॉब्लम्स व्हेन यू आर ओके विथ योर ऑल द कॉन्सेप्ट्स. ओके, कटिंग ऑफ मासेस वगैरह का एक छोटा सा कॉन्सेप्ट है विच इज वेरी इंपॉर्टेंट फॉर द इलेक्ट्रोस्टैटिक्स ऑल्सो. मैं आपको छोटा सा डिस्क्राइब कर देता हूँ यहाँ पर. हाउ टू टेक द एलिमेंटल पार्ट्स. नेक्स्ट साइड हेडिंग इज how to take the elemental mass. How to take elemental mass. Okay, first one dimension bodies. We defined a term here called as linear mass density. Linear mass density represented by letter lambda. Okay, that means mass per your unit length. So lambda is equals to dm divided by dx. Unit is kg per meter. Okay, so you remember formula here right now. For one dimension body, cutted mass divided by original mass. Cutted mass divided by original mass is equals to cutted length divided by original length. Just to remember, I have given, we don't have something like anything like cutted mass or original mass part of relation, just to understand it. Like example, thin rod or wire. Okay, if I'm taking like this as a thin wire of length L, and mass of this one is, total mass is right now capital M. If I take one small element in this one, mass of this one will be equal to dm, and width of this one will be equal to your dx. Okay, so now for this one I need to calculate dm. So it is cutted mass divided by original mass is equals to cutted length divided by original length. So dm is equals to m divided by l into your dx. So it is dm is equals to m by l is known as linear mass density lambda into your dx. Clear? Chalo. Next one. Surface mass density.
Yes, sir.
Surface mass density for two-dimension bodies. In the bracket, two-dimension bodies. Example is thin plate. Thin plate. Or circular plates. Or circular plate. Okay. Let's say for example, there is a circular plate like this. And total, it is a like plate. हम लोग जो खाना खाते हैं ना, वैसी वाली एक plate है, which is having the mass throughout its area. So two-dimension body means we take the area into consideration. So this is having the mass throughout the body right now for. Okay, और इसका रेडियस है बेसिकली, मान के चलो right now for me capital R. If I take one small elemental mass in this one like this, this is your elemental mass, और इसका रेडियस हो गया स्मॉल r, इसका मास हो गया dm. इसका एरिया हो गया dA, टोटल का एरिया हो गया कैपिटल एल, टोटल बॉडी का मास हो गया कैपिटल एम। तो अगर मुझे एलिमेंटल मास निकालना है डीएम, तो क्या करोगे यहाँ पर, कटेड मास दैट इज नथिंग बट डीएम डिवाइडेड बाय कैपिटल एम इज इक्वल्स टू कटेड एरिया लोगे यहाँ पर डी ए डिवाइडेड बाई ए। सो इट इज डीएम इज इक्वल्स टू एम डिवाइडेड बाई ए इंटू योर डी ए, लेंथ के बजाय एरिया लेना है। सो इट इज डीएम इज इक्वल्स टू वी रिप्रेजेंटेड बाय सिग्मा इंटू योर डी ए। तो सिग्मा विल बी इक्वल टू हाउ मच फॉर मी, मास डिवाइडेड बाय एरिया, मास डिवाइडेड बाय एरिया इज नोन एज सरफेस मास डेंसिटी। इसकी यूनिट्स क्या हो जाएंगे बेटा, केजी पर मीटर स्क्वायर, एरिया इज नथिंग बट मीटर स्क्वायर। am I clear? And the last one is your volume mass density, third one is your volume mass density represented by letter rho. This is for your three dimensions body, example sphere, क्यूब, कोन वगैरह सबके लिए। अब इसके लिए क्या करोगे, यहाँ पर जो फॉर्मूला लिखोगे, कटेड मास डिवाइडेड बाय ओरिजिनल मास इज इक्वल्स टू कटेड वॉल्यूम डिवाइडेड बाय ओरिजिनल वॉल्यूम। सो कटेड मास विल बी इक्वल टू ओरिजिनल मास कैपिटल एम डिवाइडेड बाय वी इनटू योर डीवी। सो इट इज डीएम इज इक्वल्स टू रो इनटू योर डीवी, रो इनटू योर डीवी। सो यहाँ से लिख सकते हैं अपन रो इज इक्वल्स टू डीएम डिवाइडेड बाय डीवी, दिस विल बी द linear mass density. Volume of the sphere will be equal to 4 by 3 pi into your r cube. Clear? So थोड़े टर्म्स है, you need to remember. Gravitation में आपको मास की जगह चार्जेस लेके करना है बेसिकली. So just remember the basic formula, that is cadet mass by cadet original mass is equal to cadet length by original length. ओरिजिनल लेंथ, या इसको हम लोग कैसे लिख सकते हैं बेटा, ऐसे भी लिख सकते हैं, that is equals to cadet length, or you can say that cadet area or your cadet volume divided by original length, or we can write this one as of your original area or original volume. Clear?
Yes.
Okay. आप लोग एक बार पूरे फॉर्मुलेस रिवाइज कर लीजिए बेटा. इन अ सेशन ऑफ ए क्लास विल ट्राई टू डू द प्रॉब्लम्स रिलेटेड टू द कंप्लीट ग्रेविटेशन, बट बिफोर दैट यू प्लीज ट्राई टू कंप्लीट योर पीवाईक्यूज. ओके, कल क्लास रहेंगे हम हमारे एज यूजुअली, मंडे ट्यूसडे क्लासेस विल नॉट बी देयर, सो मेक श्योर दैट यू ट्राई टू कंप्लीट द पीवाईक्यूज. और कल एक 20 या 10 क्वेश्चन जितने भी हो सके उतने एक्सपेक्टेड और अच्छे वाले क्वेश्चन इसमें से कर लेंगे. ठीक है, फिर इफ पॉसिबल विल ट्राई टू रिवाइज विद सम ऑफ द शॉर्टकट्स रिलेटेड टू द ग्रेविटेशन. ठीक है, चलिए टेक केयर बेटा.